Welcome to 4.3 polynomials. So there's a lot of definitions that we're going to go over, and hopefully I'll be illustrating what we're talking about with these things here. So this right here, let's talk about this. The degree of a polynomial is the exponent or sum of the exponents if it has multiple variables. So this right here, it's a monomial, meaning one term. This right here is a binomial, meaning it has two terms, and you can see these are the terms. 2x is one term, 3y is a term. Under here we have a trinomial, 2x squared plus 3x plus 5, there's three terms. Now terms are separated by addition and subtraction. That's how we define these terms. Okay, so this right here, because this first one right here, this monomial, because it's 2x to the first, that implied 1 here, this is a first degree polynomial. Same thing in the second one, because the x is to the first and the y is to the first power, that's a first degree polynomial. Now this trinomial right here, because x is to the second power, the highest powered term is the second power term, so that's a second degree polynomial. And then this third one, or this fourth one down here, where it has more than three terms, is just generally called a polynomial. And this is a third degree polynomial because the highest exponent on any of the variables is 3. Okay, so that's the degree. The degree of the term is the degree of the individual term. The degree of the polynomial is the highest degree of any term. So once again, third degree polynomial, second degree polynomial, first degree polynomial, and first degree polynomial. Now, all of these that are up here are said to be in descending order, because as we read from left to right, the degree of the term is decreasing. So if you notice this polynomial, we have a third degree term, a second degree term, a first degree term, and this 2 is actually a 0th degree term, because there's essentially, we could think of that as, we can think of 2 as 2x to the 0 power, because anything 0 power is 1, so that's a 0th degree term. So that's in descending order. As we read from left to right, the powers of the exponents go down. We could have an ascending order, where the powers go up as we read from left to right, but generally speaking, we want this in descending order. That's how I would like to do this. Now, terms, like I said, are separated by addition and subtraction. So, one term monomial, two terms binomial, three terms trinomial, and more than three terms is a polynomial, and we can denote these. We've talked about like terms and combined those in the past. We're going to have like terms with these polynomials as well, and like terms have the same variables, and each of the variables is raised to the same power. So to add or subtract them, to combine like terms, we add or subtract the coefficients. So once again, if we look at this first polynomial here, the coefficient of that is 2. And then if we look at this has the second one, this has two terms. The coefficient of the 2x is 2, the coefficient of the 3y is 3. Here we can read the coefficients of this trinomial: coefficient 2, coefficient 3, coefficient 5. And that's what we have right there. Now, when we evaluate a polynomial, we're plugging numbers in. We're using that property of substitution to plug numbers in here. So in this example here, if we have this polynomial 5x plus 6 minus x squared, first of all, this is a trinomial, and it's a second degree trinomial because the highest power of any of the terms is 2. When we're evaluating this when x equals 2, we're plugging 2 in for all the x's. So there we'd have 5 times 2 plus 6 minus 2 squared. So here we have 10 plus 6, and then the 2 squared is 4, so we have minus 4, which gives us a grand total of 12. Now, if we're evaluating this when x equals negative 2, we're plugging that in for the x's. And notice I'm plugging these in parentheses in for the x's. So we have 5 times negative 2 plus 6 minus negative 2 squared. Here we have negative 10 plus 6. When we square the negative 2, it's a positive 4, but then this minus here means this is minus 4. So then negative 10 plus 6 minus 4 is going to be negative 8. So that's how we evaluate a polynomial. Okay, so now with this last one, we're just doing a couple different things. We're determining the degree, identifying the terms, and the coefficients. So this right here, the highest power of any of the exponents is 5, so this is a 5th degree polynomial. Now, the terms are negative 7x to the 5th a 2x to the third, and a 6. Okay, those are the terms. The coefficients, well, the coefficient of negative 7x to the fifth is negative 7. The coefficient of 2x cubed is 2. In this last term, the coefficient is the actual term because it's a 0th degree polynomial. So then if we look at over here, because the highest power here is 6, this is a 6th degree polynomial. The terms are x to the 6th, negative x squared, and 2/3. So those are the terms. And then the coefficients. The coefficient of x to the 6th is 1 because there's this implied 1 out here. The coefficient of negative x squared is negative 1 because that's a negative 1 right there. And the coefficient of 2/3 is in fact 2/3. So getting used to the terminology of the polynomials is important because I'm going to be referring to these things by name as we move on in these sections. So coefficient, term, descending order, like terms, those are all really important. All right, see you next time.